Okay, so we're going to do a mole to mole calculation, and as we've learned before, the unit that you start with, okay, the unit that's in the given, and also I've been teaching you to label with what it is at the beginning, because if you copy the unit and what it is to the bottom, that'll cancel, and the unit and what it is that we're looking for will be on top. It will end up in the answer. Okay, those are skills from Unit 8 that we're now using in Unit 9. All right, on this question right here. A person collects 5.7 moles of oxygen. Question is, how many moles of potassium chlorate are used? Okay, so let's set this up. Remember, we put the given, and we have the unit, and what it is, and oxygen is O2. As a hint, you can look at the equation, oxygen is O2. And the given goes over 1, just like we've always done, right? The given is over 1. Now, in our answer, do we want moles of oxygen in our answer? No. When we want to cancel something out, do we copy it to the top or to the bottom?
The bottom.
The bottom. So, moles of oxygen's here. We're going to copy it to the bottom, like throwing it away, making it recycle, throwing it to the bottom. Okay? So, moles of oxygen is copied down here so that it will cancel out. Okay? And now, again, what are we looking for? Moles of potassium chlorate, right? So, moles. And if you've forgotten what chlorate is, on the back of our periodic table, okay, chlorate is ClO3. So potassium chlorate will be KClO3. KClO3. Moles of potassium chlorate. Okay, this is what I'm looking for. What you're looking for always goes at the top and at the end. Okay, I mentioned to you earlier about mole ratio. Do you see how moles is on the bottom? The first time that moles is on the bottom, I know I'm doing the mole ratio step. And when I'm doing the mole ratio step, moles goes on the top. Let me label this. This that we've just learned about is the mole ratio step. Okay, mole ratio step. And it's the given on the bottom, and it's the unknown at top. Always, 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 always. And as the pattern shows, we're going to use coefficients to find the numbers. Okay? We're going to use coefficients to be the numbers in a mole ratio step. So if I look at the equation, what's the coefficient on oxygen? 3, right? You see how O2 has a 3 in front? Okay, so that's where my 3 is coming from the equation. Okay, and look at KClO3. What number's in front of KClO3?
2.
A 2. And that's where my 2 comes from. So again, a mole ratio step, just like it says here in the notes, it's going to use coefficients. Okay, this right here is the mole ratio step. Now, what do we do with numbers on the top? Do we multiply or divide on the top? Okay, I hope you remember to multiply. So we're saying 5.7 times 2 times 2 divided by 3. Nobody really cares about dividing by 1. I don't either, because it does not change the number. But when I divide by 3, it does change. So I definitely have to do that. Okay, so we get out our calculator. And today the phone calculator will work because we're not doing scientific notation at all. 5.7 times 2, divide by 3, equals, and the calculator says 3.8. Okay, let's see which units did not cancel. Well, moles of oxygen canceled because it's here and here, they're gone. So if those are gone, what's the only unit that did not cancel?
Potassium chloride.
Right, moles potassium chlorate. And that's how we get moles potassium chlorate as our label. Number, unit, and what is it? We're finished. That's done.
Man, we gotta do this like 3 more times.
Okay. Now I'm going to stop the video because the video will be too long, but we are going to do some more.